I write a compiler for a simple imperative programming language called Elna, and previously I implemented static arrays and also more complicated expressions, so that field access, record field access and array access can be mixed, and so that we can access arrays inside fields and fields inside, or records inside arrays. And today we will test how it works and whether it works. Basically, so I have a multi-stage compiler there, where each stage is based on the previous stage, and I implement particular features in one stage, and they can be then used by further stages. So the compiler is self-hosted, and since we implement features one by one, the current compiler is not finished, so we cannot use all features that I planned for the programming language, because they are not yet implemented, and the compiler is written in the programming language that is implemented itself. So we were at stage 18 last time, and the first thing that we do, we execute rake convert. It is a task that will update the next stage, the stage 19, and make it the same as the stage 18th, so that we can leave stage 18 and continue with the stage 19. And we open the source code. I need to resize the screen, and now we can write that it is the stage 19 compiler. We can remove these comments since they are from the stage 18, and we also need to remove some test code. So this is code I added to test the previous stage, and I think I had a function f somewhere. Exactly, so we can remove the call and the procedure itself. Now we can build this stage. For that we call Ninja. And it compiles. So I have in the 3 address code, I have so-called instructions, and each instruction has an operator assigned to it. The operator is just enumeration. These are basically possible operators, and each instruction has operands, and since this is 3 address code, each instruction can have 3 operands. And since I didn't have arrays before, I just allocated a chunk of memory for these instructions, 44 bytes, and yeah, they have some additional fields, and use this code so I just defined manually functions that are basically accessors, so getters and setters, and I passed a memory block to it, and for example the operand number, and they calculated the offset from this memory chunk and returned the value or changed the memory at this memory position. But now we can go to this operator representation, and just below it we can now define ELNA TIC instruction type. It will be a record. Actually, at first we need an operand. I think. I hope that I haven't, or I have ELNA TIC operand already. Yeah, well, I would say let us first rename this ELNA TIC operand into ELNA TIC kind, and this thing is probably used quite a few times, so we will just replace it with a regular expression. So we say that we want to replace ELNA TIC operand with ELNA TIC kind. Okay, that worked. Yet now we come back to this ELNA TIC operator, and we wanted to have a ELNA TIC operand here, and it will be a record. And the current operand representation contains 3 fields. This is the operator kind that we actually need. So we are going to move this enumeration so it is defined before we need it, and we say that the type is ELNA TIC kind. Then we have the value. It will have a generic type of word for now, and some operands also have a length. For example, if the operand is a string or a symbol, a string basically, then value will be a pointer to the string, and length will be its length. And now we can actually define the ELNA TIC instruction. it is also a record, and such an instruction has an operator of type LNTIC operator. I think it has a next field. So let us look at the current definition. These are these functions. So kind has actually an offset +4. So list is probably yeah, it looks like so instructions are a list of instructions, and the first element of the instruction is basically a pointer to the next element of the list. So which we will just call it next and say that it is a word, because I probably cannot reference the type itself yet. And then we only have the operands, and the operands is an array with 3 elements of type LNTIC operand, and that should be actually enough, but it doesn't compile. If I remove the last field, then it still fails. Next word, that actually looks fine. If I remove the record, then it compiles as it seems. Do you have a problem with the name? No. Okay, we still have a problem using custom types as fields. Oh, I think, yes, LNTSC operator defined after. So the order of the declarations is important for now. I hope that someday we will not depend on the order of the declaration, but now to use a type, the type should be defined before it is used. And I did it wrong. No, this is this type here. So let us check it yet, it still fails. Because I do not allow comments in the records yet. It is another artificial problem that we have to fix later. And now we can put it back and hope that it compiles this time. So yes, it works now. And now we can look actually at these instructions. So I think that this instruction LNTSC instruction size can be replaced. Do we have 44 bytes here? So 4 bytes, 4, these are 8, and each array element has 12 bytes as its size, so it is 44. We can replace this LNTSC instruction size can be replaced with a trait size, so a size of operation with LNTSC instruction as its argument. And now did I copy it? And now we can try to compile it. And it should already work. Oh, this is actually the only place where it is used. Yeah, then I set the kind. So now this would be probably the next function, but we can remove this one already. Then this LNTSC instruction set kind, it can be replaced with a field access. So we can say that this result1 variable can be renamed in result, and this one can be replaced with result kind is kind, and then this line can be removed. It fails. Or because result doesn't have a proper type. So result is a pointer to LNTSC instruction. And it is not a kind, I think it is really operation. LNTSC instruction create. Yeah, this is operator. So, and now we can remove also this procedure. Elna TAC, what was it? Instruction get kind. Set kind can be removed now. Replacing the get kind procedure will be more fun, since it is often used, and we also need to set the type for the instruction because I didn't have this LNTC instruction type before, but the compiler should know the type of the record to calculate correctly the offset to its fields. So we will just look for this for this procedure and fix it one by one. And this is the first occurrence, and we have here this instruction as argument. As I said, it should be then Elna TAC instruction now. I hope it's fine. And now, since the compiler knows that it is a Elna TAC instruction, we can access its fields and, for example, say that instruction kind is the operator. Oh no, it is used only once. I just say save it in a variable and then use this variable everywhere. Actually, we can replace this this instruction kind with the field access. Not sure if I should. Actually, let us do it. Why do we need this variable? I hope that it's that it compiles still. Looks fine. To make it a little faster, we will just try to replace it with a regular expression, and we replace, then basically let us replace instruction kind with else if what was it? TAC instruction operator. Okay, then we check whether it compiles. It does, I think. And now we can continue. We have a few more cases here that we replace manually. Okay, I think that's it. And if we do not use this variable anymore, and we don't, then we can replace this assignment and we can remove the variable itself. Now we can remove the function. So this elna.tac instruction get kind. So this procedure can go. We do need elna instruction list concatenate. Then we have these operand procedures. And actually we also had this elna.tac instruction create. I will keep it for now because it does some things like setting the kind and set the next list element to 0. We can let us do the compiler later, but currently the memory can be just garbage, so we need to set these things to 0, or better to say to nil. And we will rename this procedure so that it doesn't begin with an underscore. It was earlier a requirement that all procedures start with underscore. It isn't needed anymore, so we can rename it, and I want just to save what I already did, so that if I break something that I can revert. Okay, and now we can just replace this thing with a regular expression, and we say instruction create, replace it with elna.tac instruction create. Okay. Yeah, and now we have this set operand procedures. I probably can also have this, can keep this set operand procedure, because we cannot, because here we can just define operand in one line. If I remove this procedure, I have to do it with three assignments, where I assign each field in a separate assignment instruction, because we do not have a complex type construction yet. So I will keep this procedure as helper, but not as helper procedure, but we will modify it a bit. So we will say that word is a pointer to an elna instruction, tac instruction, and then we will get rid of this offset calculation. what we actually need, we take this, then we need to dereference it and access the field operands. The operand that we need is the operand n, and we want to access, for example, type. It's not kind, it's type. Yeah, operand type is it is kind. So, and we assign operand type to it. It doesn't crash, at least, so we assign the remaining fields being this operands and value, operand value, and the last one is this length operand. And I hope I can remove this stuff then. Okay, at least the procedure has become shorter. So, and we are going also to rename this one. So elna TAC instruction set operand, it will be now elna TAC instruction set operand, but without the underscore. So and now we need to take care of the get operand functions. I have actually a LNTAC instruction get operand function for each operand field, for example for type, for value, and for the length. And this can be replaced with the field access. So TAC instruction in this case should be an elna TAC instruction pointer. And let us look there. We do not need these variables anymore, I think. So we have yeah, operand type is tested here. This instruction operand number. Yeah, variable is shorter because we need to access the array and the field there. It is not as short as accessing the operator of the instruction. So yeah, we just remove it. Write that we want the operands field. We want the field operand number, and we want to have its its kind. Seems fine. And the two others are basically the same. So this would be DSC instruction operand number kind length, and this one would be the value. And we can actually change the order a bit, and this one is value is set, and we can remove then this call, and it doesn't work because I have a typo. So let us find other usages. This is the next one, and it is basically absolutely the same. Can I just copy what I already had? So we can just copy it and paste it in here. Then we can remove these 3 lines, and we should set the argument to the proper type. This is now another advantage I had everywhere Word as type. Word is just a generic type in absence of a proper type checking, but now we're slowly replacing these word types with the real, correct types basically, which is a good thing, I think. And this is not the same. So we have a TSC instruction and next instruction in here, and we can replace this TSC instruction type. This is an TSC instruction, and then we say that LHS is it is a different thing. This is an RTL function. This is actually wrong. No, it isn't wrong. So it gets a TSC instruction as argument, and it converts it to an RTL instruction, so to an assembly instruction. But it is just a different path. Okay. I hope it was fine that I replaced the type. Yes. And the next one is this function, and it would be pretty great if I could just copy these 3 lines and paste them in here. Then I can remove these 3, I think, and it calls then LRTL set operand. We should get rid of this procedure, but it is used. Okay, we do it a different time. So here we can write this instruction. The instruction just copies the operand values as is, it it isn't really fine because RTL instructions and TAC instruction are not the same, but some of them are defined with the same memory layout, so it works, but it shouldn't actually work this way. Now I wanted to replace this 3, and I think that I lost the previous definition. It was operand type, for example, is this instructions. This is this 3. We can paste them in here and see if it compiles. It doesn't. Because this instruction. Okay, I messed something up, as it seems. RTL copy operand. Okay, this is the working version. What is changed? So we copy this 3 again, and operand number isn't called operand number, but just number. This will be the error probably. And this instruction should have its type. Okay, then we go to the next usage. So LNTSC instruction get operand value, and here we need it in current argument. Oh. I adjust manually a pointer here. Okay, I probably will look at this place later. What is it? RTL call. And it is instruction get operand value. So it converts a call instruction and here we would basically say that we want the operands field and we want the second operand and we want its value. We do want its value and we do want its length. So operands to length. And directly after that we have two other instructions that two other statements that get the value and length of the first operand and they aren't used. Okay. Then the variables can go as well. Instruction get operand value. What was the TIC instruction? This is the same procedure. Okay, let us copy it and modify. So this one will be type, and it is the kind, of the third operand. Then we have argument value being the value of the third operand, and then argument length is its length. Okay, we actually use these variables only once. I can just replace them, I think. I'm not sure how I should to indent it. Sometimes editors indent it twice, so basically so. Yes, this actually works. So this thing can be replaced with passing the whole record to the call, but we do not support it, but we will one day. I think that this argument length is used here, and here we have what? Length, value, and type. So we use length, but value and type aren't used anymore, if I'm not mistaken, but we try to compile it and it fails. If I restore them, it doesn't fail. So one of them is still used. Let us check. Argument type is used in here. Argument value, okay, they are used. So here we handle another TAC instruction, And we also have these 3 variables, meaning that we can copy paste it and replace these procedures with the field access. The operand number is 2 and TSC instruction is a TSC instruction, so we can remove these 3 lines now. A tile instruction set operand, and then we do not have anything. This is actually the same. We can replace them with the calls with the field access directly, and it passes only the value and length there. What do I do with the type? So I compare the type here. Yeah, let us pass value directly and operand length directly, and then we replace this thing in the type check as well, and then we can remove the assignments. And we can remove the variable declarations. Okay, what is actually the next procedure? I'll lot with the TSC instruction again. So this is the TSC instruction, and we'll add here the operand value. This is not interesting, but we have here, yeah, it's basically almost the same. And here I do the same nonsense, I think. I set the tile instruction using the values from the TSC instruction, but they aren't the same. So this will be TSC instruction operands to kind, and the other 2 are similar, but the one is value and the other one is the length. Okay, these 3 can go, and the declarations as well. Then we go to the next instruction, and this seems to be already handled. So do we use this LNTAC? Let me write the name of this procedure for later so that I can look into it. TSC instruction get operand type. There is still one usage of all three things, and they are used only once, I think, again. So we can just replace this operand type with TIC instruction. Do I have the correct type here? Yes, I have. So we just replace this operand type with the TIC instruction dereferencing operands. We need the first operand and we need its kind, basically. Then we can use them here. So we just say that this thing here is the value and then the length. So okay, operand type isn't, and it isn't used in this function anymore, so we can probably remove all three variable declarations, and the compiler still can compile itself. It would also mean that this procedure isn't used anymore, so it can be removed. This procedure isn't used anymore and can be removed. And this procedure too. So and this is done that. And we have actually absolutely the same for the RTL instructions. So for the assembly instructions, they are similar in their memory layout. So an RTL instruction has also three operands at maximum, but it is actually probably not always the case. My compiler currently works only for the RISC-V, and for RISC-V it is enough, but it can be that that more or less operands are needed for other architectures. But currently, since we have only RISC-V, we will do the same for this RTL instruction as we did for the TIC instructions. So here we have the operators first, and then we have the RTL operators as well. We have RTL operand. We renamed this thing, I think, into kind. So let us check if we have something called RTL kind. We do not have it. I save what I currently did, what I just did, and then I can rename this type name RTL operand into ELNA RTL kind. We save the changes and compile it once again. ELNA TIC kind. Then we have TIC, not TIC, RTL kind. And then we have the RTL registers. So these are basically RISC-V registers. And what do we need? We need a type for the operand, and we need a type for the instruction itself. So we just copy the available types and let us put them here. So here I have this enumeration and then two record definitions. So we can remove the new lines here, and we should rename this TIC into RTL register transfer language, and the type of the operator is of course not a TIC operator but an RTL operator, and the operands are RTL operands, and the operand kind is RTL kind. And first I replace this ELNA RTL instruction size procedure. This is then basically just size of the ELNA RTL instruction type. The compiler can get the type size now itself without a need to specify it manually, and this actually should just work. And we have then other places where it is used. So we say that this is also RTL instruction. Oh, it's the same also. Okay, we need to go back. I revert it. I thought that I have forgotten one character in the size trait. So it doesn't compile because it says that it doesn't know the type. ELNA RTL instruction. And we can use the same expression in the memcpi call. Okay, this is the last occurrence, I think, so we replace it with Elna RTL instruction, and we also can rename this result1 into just result. And we can remove you. Now we have this set kind and get kind procedures. So Elna RTL instruction get kind. Yeah, it is used just 2 times, and we actually just use it in a switch case again. So this is an instruction list. Oh, I have already a type for these instructions. I call them instruction list. Yeah, this instruction list is basically a base type, and so I plan to implement type extensions so that the types can extend to other types. It is an Oberon feature, and we can just keep this Elna instruction list as it is, and later instead of using next here, we will write Elna instruction list, meaning that we extend this type, and then the fields from the Elna instruction list will be inserted in into the Elna RTL instruction. Or maybe we can get rid of this Elna instruction list. I do not know if I need to be able to be able to mix them in some way so that so that they have a one base type. These instructions are actually pretty different, and here it is the allocation pass. One is allocation pass done. So but I need some functions that work on both instruction kinds, like concatenation of the instruction lists. So we will need a base type for them. But here actually this is the allocation pass, register allocation pass, not really register allocation pass. It allocates stack spots, space for the temporary variables and pseudo registers, and the type of its argument is actually always an RTL instruction, and we can write it this way. I think that I hope that compiles. And then we can replace this instruction kind with instruction, was it operator or kind? Operator, I think. I have this function here. So elna RTL instruction has next and then the operator. So this one would be basically instruction operator, and we will check where else it is used. Here are just a few places, but not that many. I just replace them manually. Shouldn't take too long. Oops. And we are almost done. And I hope then that I can remove this variable now. So this was the instruction kind. And now we have this operand type variables. Here it is checked basically once, and then they are reassigned. Yeah, okay, let us replace the operand type with the instruction operands one kind. I think it was kind. Exactly. Then we can pass the same stuff to these procedures, but change the field name. The one is the value and the another one is the length. And So then we set the kind of this instruction. Or basically I replace the move instruction with the store-bought. That makes sense in some cases, so we can just actually write that instruction operator changes to the ELNA RTL operator SW, and it breaks, but now it compiles. Okay, so then we get these three operand parts at first operand type from the second operand, and then we use the operand value and operand length. So it should be fine actually, I think. We can remove these assignments then and see if it still compiles. It doesn't. Operand type. Oh, I changed the values because move and store instructions do not have the same order of operands. What I actually do is that I set the first operand, for example type, to the type of the second one. So this is actually what is done there. Value and length and value and length. I can just copy them with memcpy or whatever, but well, but it kind of doesn't want to do what I want it to do. So let us revert to the latest changes. Probably because I set it then. No, I removed this instruction. So first I assign the first operand, and after that I set the second operand and this operand type and so forth. They aren't used anymore then. Okay, I'm going to revert my latest changes because something is definitely broken. This worked, I think, and we will just try again and just say that we want assign to the first operand in the instruction, in the output instruction. I hope the instruction has the correct type. It does. So this would be operands 1, and we want to set its kind to the kind of the second operand. It works, and then I put it after that, then it still should work, I hope. Yes, it does. What about value? Value. Okay, I did some stupid mistake before, but it seems to work now. Just redoing this thing was actually easier. So this assignment works. We do not need this assignment then anymore. And we do not need these 3 assignments above. Then we have here this operand length and value, but they are not used anymore, as well as the type itself, so they can just go, I think. And then we have this. Is it the same actually? So we check the operand type. It is actually the same as here, but not the first operand, but the second one. And after that, we use this ELNA alloc variable with operand value and operand length. We had actually the same thing here. I can just insert it here, but we take them from the second operand, but everything else should be fine. Then we change the instruction kind to the load word, so not as W but LW, and then we set the second operand to some values, but actually we do not need these 3 variables anymore. So this looks fine. Let us at least finish this function. So we assign here this operand type values again, and I use it in this if statement, and it would be then instruction operator. This is the operand type, and operand value is used in this allocate variable thing. Instruction operator word operand type. And then we have this allocation thing. it will be the same, so just get the value and then the value length. Okay. And then we change the kind. Instruction kind is LOTWord, so we say instruction operator is ELNA RTL operator LOTWord. Okay, then these assignments can go as well. And we can remove the variables probably. So these three actually. ELNA RTL instruction set operand, this will remain. So here we have get kind, get operand value, get kind, print up, print value, print length. Yeah, here are still a few places where this stuff is used, but I think that we tested the features that were implemented in the previous stage enough, so that we know that that they are correctly implemented, and now we can use arrays and array access in our compiler code. And I could see that I can really reduce the amount of code, because all the assignments are easier. I can just pack values into an array or records, and I can access things easier, and it reduces the amount of code and the amount of temporary variables that I had to use to retrieve particular values. And the remaining replacement of these instructions with the new instruction is not particularly interesting. It is actually the same as I did now, and I will finish it a bit later. But for this video, I think that I did enough of it, and therefore I will finish it here.